In this screencasting, we are doing this problem. It is under Newton's laws section. So, in this sketch, there is a force of 120 newtons applied vertically on this block B of mass 10 kilograms. And block B is connected to this block by means of the string which passes over this frictionless pulley. This block A is of 5 kilograms in mass. There is the friction between block A and its surface, and of course, if there is coefficient, that means there is friction in between. To draw the free body diagram on block B, you will need to indicate the applied force, indicate the tension force, and the weight force. But if this block B was drawn upwards with no string attached to connect another block, there should be no need to indicate the tension force. There would be an applied force and weight force only. Let us see how to calculate the magnitude of the friction that exists between this block and the surface. The statement provides the coefficient kinetic friction, that means the system is moving, which we are using this formula to calculate such friction. Note that there is static and kinetic friction. Static frictional force is the force that prevents two surfaces from moving relative to each other when they are not moving. And the kinetic frictional force is the force that slows down an object that is already moving. Static frictional force is for a stationary object, and kinetic frictional force is for moving objects. If the system was stationary, we would be using this formula to calculate static frictional force. Back to the kinetic friction formula. This is a coefficient symbol where we put this coefficient number. This n is the normal force, which is equivalent to mass times acceleration to gravity. That is 9.81 times 5. Calculating all these together, we get kinetic frictional force is 14.7 newtons. But we are not given acceleration. Now we are calculating the tension force on block B, which is the tension on this side. Net force of block B is equal to mass of block B times the acceleration of the system. Net force on block B is the sum of applied force plus weight force plus tension force. And on this side, block B mass is 10 kilograms. Applied force is greater than weight and tension force. Applied force is 120 newtons, then minus weight force, which is 10 times 9.81, and minus the tension force. We put minus signs here because weight and tension force oppose the motion of the system. Applied force is pulling up. Tension and weight are pulling downwards. From this step we get 22 minus t equals 10 times acceleration. We leave it as so for now because we have two unknowns on this. We label it equation 1. Note that tension on block B is equal to the tension on this side of block A. Now we calculate net force on this block, where the net force is the sum of tension force minus kinetic frictional force. Tension is unknown. Frictional force is 14.7, mass of block A is 5, and acceleration is unknown. We label it equation 2. Then we solve these two equations simultaneously. The t goes off because they minus each other. We find acceleration is 0.487 meters per second squared. We take this acceleration value to substitute in either of equations to find tension force magnitude. By doing so, we find the tension force magnitude is 17.13 newtons.